The ketogenic diet has gained a foothold in the world of cancer care, not through the mainstream medical system, but largely through patient communities, blogs, and wellness influencers who tout it as a metabolic weapon against tumors. Its logic is seductive. By depriving cancer cells of glucose, their primary fuel source, one might theoretically starve the disease. But while the science behind this idea has shown some early promise in animal models, its real-world application in human oncology is far murkier and potentially dangerous. Preclinical studies in mice have demonstrated that in certain types of cancer, ketogenic diets can slow tumor growth or enhance the efficacy of treatments like chemotherapy or radiation. These findings have been seized upon with enthusiasm by those looking for alternatives to conventional care. But here's the reality. Translating results from mouse models to humans is notoriously unreliable. Rodents have different metabolisms, shorter lifespans, and controlled lab environments that bear little resemblance to the complexities of human biology, cancer variability, and clinical care. Promising interventions in animals often fail entirely in clinical trials, and when it comes to ketogenic diets, the human data is far too limited and inconclusive to support broad recommendations. In fact, most human studies involving ketogenic diets in cancer are small, short-term, and methodologically weak. Case reports and pilot trials have shown some patients can tolerate the diet, and a few have experienced stable disease for a time, but causality is difficult to establish, and confounding factors abound. Larger, more rigorous clinical trials are still underway, and until results are available, it is irresponsible to treat the diet as anything more than experimental. Worse, it is sometimes promoted as a primary treatment approach, diverting patients from evidence-based care with unsubstantiated hope. For patients with cancer, particularly those undergoing active treatment, the risks of restrictive diets like keto are real and underappreciated. One of the most serious threats is unintended weight loss and malnutrition. Ketogenic diets are inherently low in carbohydrates and fiber and often result in a caloric deficit. In the general population, this is marketed as a benefit, but in oncology, weight loss can be deadly. Cancer cachexia, a syndrome of muscle wasting and metabolic dysfunction, affects many patients and is strongly associated with poor outcomes. Reducing body weight or lean mass further through dietary restriction can accelerate decline, reduce treatment tolerance, and increase mortality risk. The keto diet may also compromise gut health. By eliminating or minimizing whole grains, fruits, legumes, and other plant foods, it limits sources of prebiotic fiber critical for maintaining a healthy gut microbiome. This microbiome plays a pivotal role in regulating inflammation, immune function, and even drug metabolism, all central to cancer progression and recovery. Disrupting this balance can have unintended consequences that may offset any theoretical metabolic advantage of ketogenesis. Another layer of complexity is the diet's sustainability. Keto is notoriously difficult to maintain, even for healthy individuals. For cancer patients, who may be dealing with nausea, fatigue, taste changes, or food aversions, compliance is even more challenging. A poorly executed or abandoned keto plan can lead to nutritional gaps, confusion, and demoralization. It also places undue burden on caregivers, many of whom are already overwhelmed by the emotional and logistical weight of cancer treatment. All of this points to a larger issue: the commercialization and oversimplification of nutrition science in oncology. The idea that sugar feeds cancer is technically true in a narrow biochemical sense, but it's often weaponized in ways that lack nuance and ignore the complexity of cancer biology. Glucose is also the primary fuel for healthy cells, including brain, immune, and muscle cells. The goal in cancer treatment should not be to starve the body, but to support it, to maintain strength and function while medical therapies target the disease. There may be contexts in which a ketogenic approach proves helpful, for instance, in specific brain tumors or when used in tightly controlled clinical settings under medical supervision. But for the majority of cancer patients, the diet remains speculative at best and harmful at worst. What is most needed is not hype, but rigor, carefully designed trials, individualized nutrition plans, and cautious communication that respects the vulnerability of those facing a life-threatening illness. In the meantime, the strongest evidence continues to support dietary patterns that are rich in whole foods, plant diversity, and moderate in fat and protein. These patterns, not extreme metabolic experiments, are linked to better survival, quality of life, and treatment tolerance. The ketogenic diet may hold some promise, but in its current form, it risks doing more harm than good.